Hi guys. So I just wanted to walk through an example of the homework assignment that's due on Wednesday, just so you can see what exactly is expected of it and where some of the things are that you're trying to do. So the assignment, let me share this. Here we go. So our assignment due Wednesday. The assignment form is right here. I have that pulled up. So what you're going to be doing is using some actual county level census data to get a model for the population growth of that county. So in this page, so I'll be going through this in Excel. I'll also show a little bit of Google Sheets for whatever spreadsheet software you're using to make this. So if you click on this link, it brings you to a real official Georgia website. The data I want you to use is right here. This link, I also put the Excel spreadsheet here if you don't want to go to the page. And also I made a link to a Google Sheets version of this. And so the Excel version looks a lot like this. It has total Georgia population on top, all the counties in alphabetical order on the left. These first two columns don't use those. These are some information based on census data, and these are later estimates in July 1st of every year. So from this column D to column M are the years 2010 to 2019, and these are the columns that I'll actually want you to use. So then the instructions say pick the county alphabetically closest to you. I decided that I was going to use Clark County, where I live in Athens. So this is the row that I'll be using. This for 2010 all the way to 2019. So what the instructions say for us to do, once you've found the county you're going to use, is first enter this information into a table. So what that will look like is this. Put both these on here. So in this year, starting at this column D here, this is 2010, and so what your table will look like is years after 2010. So 2010 counts as 0, 2011 as 1, and so on up to 2019 counts as 9. And then write down your population in thousands. So here, round it, 117,403 is 117.4, 118,229, 118.2, 119,891. I rounded up that time to 119.9. So here you have to move this over. It doesn't take very long. I'm just reading things and rounding them to the nearest 100 and then writing them down. And so this will make the numbers a little bit easier rather than having these thousands. Everything will be a little more manageable when we're here. Okay. So once you've made that table with inputs 0 to 9 for 2010 to 2019, and then the corresponding output of the county population in thousands rounded to 1 decimal place, copy and paste this twice because you're going to make 3 copies for 3 different types of trend line. So you enter it once, but you copy and maybe move it down a little bit, and then move it down a little bit more. So then for each of these, you're going to make a chart. If you're working in Excel, then that means go to Insert, Chart. You want to scatter plot. And that gives us our points here. And so this part is going to be the same for all of these. They're all using the same data. So all these points are going to look the same. But what you're going to do that's different is that each of these is going to get a different kind of trend line. So linear, exponential, and quadratic, meaning polynomial of degree 2. So for this first one, if we click on here, in Excel, add chart element, you can do a little extra if you want. We can add some of these point labels. We'll make it a little bigger too. But the big thing is, let's add a trend line. And I would say give yourself these options. So you can pick the different types, but also so you can display the equation and the R squared value. So we can make this a little bit bigger. So we can actually read it, and there we go. So for this one, we'll add a trend line again. Maybe we'll label some points. Make it a little bit bigger. We give ourselves a trend line, and then we wanted exponential. And the equation and the R squared. A little bigger so we can read it. Oops, Control A. So here we have the exponential function that we saw today. E here is the irrational number E 2.718 and more. So that's the base. Because we don't know if it's kind of what the proportion is. We don't know that it's doubling or something. And when it was doubling, we used 2. Here, they just kind of use E as the base that is always used to make it more standard. But that's the base. We have the K value, and then we have the constant multiplied in front. And then we do one more. So just to keep it consistent, we'll add the data points. We'll add the trend line. So it defaults to a line, but we always want to switch it. And we said polynomial of degree 2 with the R squared in the equation. And again, I'll highlight all of this. And yeah, right, the way I've been doing it is highlight all of it, and we can go here, change the font a little bit. Okay. So these are our three models. So for each of these, we have the trend line going through them, as well as the equation and the r squared. So then we have a couple of questions. Now that you created these functions, you want to see what you can do with them. So the first one is, which r squared value is the closest to 1? Meaning, essentially, which of these models fits the best? So they're all pretty close. So the quadratic is 0.972, the exponential is 0.971, and the line is 0.970. So this quadratic one is the best. But this can really vary. So the kind of outlier here, which is kind of surprising, is that there's this really low year in 2014. And that is just what the data says. If that was up, it might be that the line fits things the best. Things really are straight. This turns out to be growing pretty linearly with a little bit of a curve. But it could be that one of the other functions fits better. So here, it really depends on whatever your data says. Next up is for the linear and quadratic models, what do they predict the population will be in 2020? So here, the data points that we have, the number corresponds to the year. So we want to know what happens when you input 10, which we don't have a data point for, but we do have a model, so we can make that prediction. To do this, and for these second two, what's really helpful is this Wolfram Alpha link here. So this, not only is it a calculator, but it has a really pretty intuitive interface. So let's say we have our quadratic one here. A method that you can use is evaluate that expression that we got. Here you'll have to put in a little caret to say raise it to the power. And we want to do this at x equals 10, which is what we want to do. We want to know, what does our model predict will happen in 2020? That year corresponds to 10 years, or that is 10 years after 2010. So the input corresponds to x equals 10, and we can evaluate that here. If we click enter, the picture is really kind of misleading. 5 times 10 to the 15th, that's really big. But here what this is saying is, take this, put in x equals 10, and do the computation. Oops, I didn't want to do that. But this does that for you, which, if you look at the points that we had, so this was, let's go this way, 130.24 is about where it should be. It's up like 0.9 or so, which is about how much this is going up. So you can do the same thing by using the line, put the formula of the line, and evaluate that formula at x equals 10. What we can also do is for the linear model, in what year does it predict the population will be double what it was in 2010? So here you'll actually have to kind of put things together. So first, this is asking you to see when your model crosses some threshold. So in what year does the population reach whatever doubled it was in 2010? So that's where we set up an equation setting the model formula equal to the value we want to know when it reaches. So going up to the linear model here, we have our formula, copy that. And now we want to solve when the formula for a model equals double the initial amount. So in here, the initial value was 117.4. If we multiply that by 2, we get 234.8. And then if we hit enter and solve this, this is something you could do exactly, but as long as we're using this for one thing, we might well use it for everything. And so this is the graph of the line that we have here. This is the exact fraction you get, but if we click on approximate form, this will give us the decimal, which is about 91.9. So almost 92 years later, so that's 2102. That's when Clark County will double. So that's the number we're looking for. And so those are the questions that we want to answer. When we turn this in, make sure you submit this file with all of your pictures, and either in a separate file, or you can below here just kind of write in question 1, answer, question 2, answer. You can put those in your document. But make sure that you include the 3 models and answer the 3 questions. And what I also want to show is what this looks like in Google Sheets. So if we go here. So I won't go through the whole thing, but I'll at least sorry, my internet's messing up. Okay. Okay, so I'll at least show you kind of what it looks like. The spreadsheet, we'll just say practice, start editing. We'll enter a few points, 1, 2, 2, 5, 3, 9.5, and then 4, 11. Okay, so you'll enter your data points in your table, highlight all of this. Again, we'll insert a chart. We want to pick the chart type. We don't want a bar graph. Go down and want a scatter plot, which has our 4 points. Okay. So we have the 4 points. If you want to go to customize, here you can change, or series is where a lot of this stuff happens. So the big thing is when you click customize and series, we can add the data labels. So let's okay. So that one's kind of off the edge. Nope, that's not what I want to be. So many tabs open. Okay. Okay. So now we need to find this thing again. Okay, all right, so you can control click or, right. Yeah, so for me on a Mac, it's control click. Get in here to series again, and we did the data labels, but the big thing is we want to get to the trend line. So again, you have linear, exponential, polynomial, where you can change the degree. We want degree 2. And then we can show the R squared, but the big thing to watch out, or that is a little unintuitive to find, is in the label. You can click use equation. So that's where the equation shows up. The R squared is there, but the label is where the equation is. And so as we change from, say, polynomial to exponential or to linear, we get the corresponding equation. And once you get these graphs, you can go through, ask the same questions that we did when we went through it in next. Okay. And once you have that all, everything ready, you can go to your homework assignment and submit it. So if you have any questions about this, make sure to reach out to me and I can try to answer them. But hopefully this video gets you an idea of what to expect for this assignment. So good luck. I hope it's instructive seeing how this model stuff actually, what you can actually do with it. And I'll see you guys on Wednesday.